We're back for more about sexual selection. Um, and I just wanted to sort of do a little reminder of what we've been actually working on, which is that we've been going through examples of these theories in order to answer a big question, which is how does sexual selection as a process, as a force, result in the evolution of traits, um, and often very odd, elaborate, showy traits within populations of organisms, within populations of animals in particular. And we've been actually spending all of our time so far dealing with intersexual selection via mate choice. So there's four different theories that underlie the ways in which mate choice by the choosier sex can influence traits in the more competitive sex was all about intersexual selection. So what I want to move into is a little bit of a discussion of intrasexual selection. And intrasexual selection, selection happening within members of the same sex, um, occurs via competition for access to mates. Um, and competition is an ecological sort of interaction that actually can play out in two different ways in all situations. So, regardless of how we talk about it in animals or plants competing for access to space, competing for food resources, mate competition plays out in the same kind of way. So, what are the mechanisms of competition that we can address? And the first is pretty straightforward. It's interference competition. Interference competition is when two individuals actually come into a fight over access to a particular resource. In this case, that's males fighting with each other for access to females. And elephant seals that we've sort of talked about, gone through, that I just like to have pictures of, they're a fantastic example of interference competition because those males fight violently with each other for access to space on the beach where they would actually get access to mates. Now, there are always questions that arise out of this kind of interference competition, and we'll come back to these a little bit, but questions of how intense should a fight actually get? How much energy should a competitor put into the fight for access to mates? And when should they give up? There's actually all sorts of models about optimal giving up time in these kinds of fights. The other sort of question to answer or to think about is how has the signals associated with these kinds of fighting evolved? How have signals for escalation evolved? All of those sorts of signaling patterns come out of this pressure for fighting for access to a particular mate. That is interference competition. The other kind of competition that we often see in mate competition situations is exploitative competition. Exploitative competition we can talk about as cuckoldry in sexual selection situations, but it's where one individual gets to the resource first, and once they occupy that resource, then it's not available for anybody else. So we often think about it with respect to cuckoldry in animals, because especially with those who have external fertilization, because a female will lay eggs, and the first individual to get there to fertilize the eggs wins. The two males competing for access to fertilization may never interact with each other, they may never see each other, but they actually get to compete with each other because it's all about sort of speed and rapidity with which they get to those eggs to fertilize them. So these are examples of bluegills, which are in your book, and where males will create these sort of nests and females will come in and deposit eggs. And there are other males who will just sneak in, sort of zoom in around the backside to deposit their sperm before that male who built the nest does. So that is exploitative competition. Now, when we think about sort of what this means, what happens to males who are bad competitors? If he can't actually compete either via interference or via exploitative competition with other males, then what are his options? And the first one is that you just don't get any matings. If you have no matings, you have zero fitness. You have no chance of getting any copies of your genes out into the next generation. No copies of your traits out into the next generation if you're a bad competitor. And that could be because in one year you're young and maybe next year you'll be a better competitor. That so you will overall in your lifetime get to have matings, but you may miss that single year. But maybe you don't. Maybe there's just something actually bad about you for whatever reason, and that means your fitness will be zero. Second possibility is that you find some way to make the best of a bad situation. We talked about elephant seals and said, right, there are, look at the beach, the pictures of all those individuals on the beach. There are a lot of females on the beach. There aren't as many males on the beach. And individual males will get up there, fight with each other, and defend stretches of beach. And I pointed out some males that were remaining in the water off the coast, just kind of 15 feet off the beach, sitting in the water. Those are males who are making the best of a bad situation. They are actually uncompetitive. They cannot get a female because they cannot win in battles on the beach. But they will hang out in the water, and if females go into the water to get food, to cool off, they will attempt to mate with the females there. Their fitness is always lower. Their reproductive success is always lower than that of males who are on the beach. But they don't have any other options. They can try to win in competition, but they will not because they're smaller, they're not in as good shape, they cannot compete for access to those stretches of beach. So they will hang out in other places. That is making the best of a bad situation. They're not really doing something different. They're just trying to kind of do the same thing without getting themselves into the middle of those fights. Now, there's a third option that males have, and that is the use of alternative mating strategies. And that's what we're going to get into a little bit on Tuesday and Thursday this week. So thinking about like, well, what does it mean when individuals actually develop or evolve, individuals don't know, when populations evolve multiple versions of mating strategies that can be used. So read up on that one because this gets into issues of frequency dependent selection. All right, bye.